Hi, welcome to the series of session on data mesh. I am Sendil. I am a big data and cloud architect. In today's session, we'll be seeing the third principle of data mesh called self-serve infrastructure data platform. So, in the previous principles, so we got an idea about the decentralized at domain level, data ownership, and data platform. We got those ideas. Now, to build, deploy, and execute a data product, we need a infrastructure. So, infrastructure may be either a cloud on premises with different technology stacks, etc., etc. To provision the infrastructure, we need a infra expert to be hired. So if you are having a multiple domains in an organization, each domain will might be having a different technology stacks or infra for which we might be in need of different infra experts, which is add a co- heavy cost to the organization when they are going with the data mesh. That is one challenge. Second thing is, let's train the existing resources, either the administrator or developer, with the with this new principles and technology stacks. There exists a challenge. They would be familiar with the legacy system technologies like Java, Python, or DBMS and all. So here we have a different technology stacks because for analytical we have a big data landscape and all, right? So upskilling them and getting them ready in a quick interval will be the real challenge. So these are the two challenges that lies in front of us. So how we are going to overcome this one? That is the first question. So what we expect, what it would be very easier is, let's have a centralized infrastructure that can be used by the all the domains on data product team in a simple way, either by single click or just by calling one interface. If they are able to provision a environment for their data product, or if they want to deploy a data product and execute, it should be a single command or interface through which they have to do it. If we are able to achieve that, it will hide all the complexity behind the provision of infrastructure stacks and data product, etc., will be hidden from the end users, which is the data product developers or other resources. So that is the idea and principle, which is called self-serve infrastructure data platform. So we have to build environment and provide a tooling or interface to the end user. Using that, they should be in a position to provision the infrastructure in a very short duration without knowing the complexities. So it's not just about the provisioning of infrastructure alone. It's about creating the data product by and its pipeline by just filling certain configurations, saying that I want a real-time batch with this type of source and this target, and orchestration of that pipelines, and access, providing getting the access to the data storage, data patterns, lineage, etc. All these capabilities are required when we are thinking about a self-serve infrastructure. So data mesh comes with a set of capabilities. So whatever I have listed is not a full list. It's just few bullet points that I added. So normally when you are thinking about here, data platform, that especially at a self-serve infrastructure data platform, you might be in need of certain storage, definitely storage, database, and for those we have to provide the access. And typically when data flows, the lineage and all comes into the picture, data quality, standardization, monitoring, logging, auditing. So every these are the set of capabilities. We'll be having some 100 plus capabilities that are required for a data platform. So if we can build a platform with these capabilities and provide an interface to the users for them to use, it will be a very effective environment platform for us. So that is what data mesh third principle is aiming for. So let me go to the next slide where we'll be seeing a logical architecture of how we are categorizing this capability into different planes and build accordingly. So there are three planes in which all the categories that we saw earlier will be placed here. So the first plane that we are thinking is the provisional plane. It will mainly include the capability of provisioning the infrastructure, storage, computation services. Either it may be a EMR or data breaks, or storage like S3 or ADLS. So all will be provisioning will be coming under this plane. Not only provisioning of these services and infra IaaS and all, it providing access control also will be coming under this provision plane. Second one is the data product developer experience plane. So this play, whatever capabilities that we are thinking at the data product level, right? Creating a data product, building a pipeline, configuring for that one, executing the data product, getting the version of the data product. All those data product developer capabilities, activities will be coming in this particular plane. The third and final plane is the supervision plane. This is at the high level where they want to see the what's happening in each data products like that. For example, querying a set of data for a particular use case from a data product or from a set of data product using aggregation. All those will be coming at the this supervision plane. So to explain this in a graphical way, here if you see here, we have a first plane, data infrastructure plane. So where you have the certain capabilities like providing access control, data transformation, orchestration, storage, networking, CACD, and all. So similarly, we'll be having a data catalog and all. Data catalog, auditing, logging, everything can be coming here. The second plane that we discuss is the data product developer experience plane, where all the data product related thing will be coming in, like create data product, read data product, version, secure, build, deploy, monitor data product. Third plane is the supervision plane, where at a high level between the data products, if you want to explore certain data by querying, that will be coming here, and managing security policies and all, it will be coming. So basically, this third principle, what it aims is to have a common infrastructure that can be um, that provides some tooling or interface to the end user. Using that, they can easily provision the infra as well as the capabilities that they require. So by doing this, the lead time for a particular capability will be very less. For example, I'm launching a data product. I want to get the infra ready. So just filling the YAML file and submitting to the interface, it will create an infrastructure for your new data product in a very shorter duration. So you don't need to wait for a long period. Similarly, if you want to get a access right for a particular storage, you have to just call some interfaces, pass some arguments to that, and you'll be getting the access in a few minutes. That is the advantage of this principle. There will be different domain, and each domain will be having a set of data products and different data product developers, owners working. They don't need to know the complexity or technology stuffs of how to provision or manage all the technology stacks, services, provide access, lineage, nothing. They don't want. They just want to understand the interface and they have to use it effectively. So this is the main advantage of this third principle. Hope I think I'm clear with this principle. So the next one that we'll be seeing is the fourth principle, which is called federated computational governance. So I'll catch you on the next session. Okay. Thank you. Have a good day. Bye.